Hey, question 8. Question 8 looks like it's a rates of reaction question. They tell you excess magnesium carbonate. Let's highlight that. Okay, my highlight failed. Let's highlight that. Reacts with hydrochloric acid at room temperature, blah blah blah, 4 minutes, 240 seconds. They ask you to suggest a reason why no further measurements were taken after 240 seconds. If you look at this graph, it seems to have stopped. Okay. So you could say 8A, the reaction has completed. Or you could also say that the hydrochloric acid has or you could say the hydrochloric acid has fully reacted with the magnesium carbonate. Okay, that's A. Part B. Calculate the average speed of the reaction in cm³ per second for the first 80 seconds. 80 seconds. I find a marking down here. My marking actually reads about 43, if you notice. 5 intervals. So first one will be 42, halfway between the next one, okay, 42, 44, 43. So it's 43 cm³ gotten total. I want an average speed of reaction. So I divide it by 80 seconds. I get an answer 0.5375, but we write it in 3 sig fig, right? So about 538 cm³ per second. Okay, that's your answer. Part B. Part C. Using collision theory, how does an increase in temperature affects the rate of reaction? Temperature. Turn to VIP notes, page 38, and you get an answer. Higher temperature, more particles have more energy, more of them have the minimum amount of energy required, they react with more impact, more frequently, hence reaction is faster. Classic answer. Okay. And then we go to part D, mole concept. See, in VIP notes, page 38. Okay, part D. Let's look at it. Calculate the volume and mass of carbon dioxide gas produced by adding 20 grams of magnesium carbonate, 20 grams in excess acid. So, step 1. Always find mole, and we are looking at magnesium carbonate. You're given 20 grams. Okay, using our formula, moles equals to mass over mR. Okay, so 20 divided by 24 plus 12 plus 3 times of 16. I'll get 0.2381 mole. Next, I use my ratio MgCO3 to carbon dioxide that I want to measure. It's 1:1, so 0.2381 will give you the same amount. Last bit, if I want to find mass, equals to moles times mR. So this time around, the mR is of carbon dioxide. So 0.2381 times 12 plus 2 times of 16, that actually works up to 44. I get an answer. 10.5 grams. And then I want to find the volume. Volume equals to mole times molar volume. Molar volume is 24 dm cube. Stick 0.2381 times 24. I get 5.71 dm cube. Sorry, you couldn't see that. Part E. I've got 25 cm cube of 1 mole per dm cube acid reacting with 20 cm cube of sodium hydroxide. Find concentration of sodium hydroxide. So, same steps again. Part E. Let's look for numbers. 25 cm cube, 1 mole per dm cube hydrochloric acid. So moles of HCl equals to volume times concentration. So I've got 25 cm cube, right? So convert that to dm cube, divide by 1000 times concentration, which is 1, equals to 0.025 mole of HCl. What is my ratio? To get my ratio, I need an equation. Did they give you an equation? No. So let's write down the equation. HCl reacts with NaOH, giving you NaCl and H2O. It's a 1-to-1. So HCl to NaOH, 1:1, 0.025 is to 0.025, okay, of NaOH. So how do I find the concentration? Concentration equals to, let's take this formula, play around with it, mole divided by volume. So I've got my mole over volume. So I've got 0.025 moles divided by 20 cm cube, which is 20 over 1000. I get an answer, 1.25 mole per dm cube. Okay, that's mole concept.